Okay, let's do this last one before bed. For the following true conditional statement, write the converse. If the converse is also true, combine their statements as a true biconditional. So the converse would say, if x squared equals 49, then x equals 7. Okay. Is this true? Nope. False. Why is it false? This is an important one, kids, because you can square -7 also to get 49. Okay? So just because x squared is 49 does not mean that x is 7. And that's an important one to remember. So that one's false. So we can't write it as a biconditional. Okay? Now, what is the converse of the following true conditional? And if it's true, write the statement as a biconditional. If either is false, then give a counterexample. Let's see. If two lines are parallel, they do not intersect. Okay? That's true, but then the converse of that would say if two lines do not intersect, then they are parallel. So I've just included a little illustration. You see this little house on the bottom, and you see these two lines, this line running across here and this line running across here, okay? They are not parallel, but they're also not going to intersect, okay? This goes this way, this goes this way. You can just imagine them extending off and never running into each other. Why is that the case? Because they're not on the same plane, okay? And when they're not on the same plane and they don't intersect like this, they call them skew lines, S-K-E-W, okay? And then so I'm going to say that's false. And I'm going to write it down here. Skew lines. So let me do that in a different, better color. Okay, that's a counterexample. Now, when a conditional and its converse are both true, you can combine them as a true. Do you remember what this is called? You can combine them as a true biconditional. Yep. And determine whether the conditional and its converse are both true. If they're both true, combine them as a biconditional. If either is false, give a counterexample. If an angle is a right angle, its measure is 90 degrees. That's true. The converse says if an angle measures 90 degrees, then the angle is a right angle. It's also true because this is the definition of right angle, is it measures 90 degrees. Okay? So we can combine that into a true biconditional that states, let me type it. An angle is a right angle if and only if its measure is 90. And I unfortunately don't have a little degree symbol, or otherwise I would add that on there. But that's it. An angle is a right angle if and only if its measure, and it shouldn't, that's not how you spell its. this it's, not the other it's with an apostrophe. It's not a conjunction of it is, it's just it's as a possession. And its measure is 90 degrees. Okay, there you go. We got a couple more in there. All right. Write the two conditional statements to make up the following biconditional. So I'm going to underline these two parts to it. We've got I drink juice and it is breakfast time. So how could I write that? I could type this to say if I drink juice, then it is breakfast time. And I could say thanks for your patience. If it is breakfast time, then I drink juice. Okay, and that's how you break a biconditional up into two conditional statements. You identify the part before the if and only if, and the part after, and you use them each as the hypothesis and conclusion once in the two definitions, okay, or in the two conditionals. Now, 28. Is the following definition of dog reversible? If it is, write it as a true biconditional. Okay, so let's write the first conditional and see if it's true. Okay, if an animal is a dog, then it is a mammal. That's fine. I like it. Now let's do it again. With the reverse of it. If an animal is a mammal, then it is a dog. Well, we know that that's not necessarily the case, but then we have a non-reversible situation. If an animal is a dog, then it's a mammal? Sure. But if an animal is a mammal, then it's a dog? Nope, not necessarily. I'm a mammal. I'm not a dog. So it's not a good definition, and we can't write it as a biconditional. It's not reversible. Okay, last one. Is the following definition of perpendicular reversible? If it is, yes, write it as true biconditional. Two lines that intersect at right angles are perpendicular. So you could say, and I'll write it out. I'll just say it out. Okay. If two lines intersect at right angles, then they are perpendicular. That's true. That's what perpendicular means. And what about the converse of that? If two lines are perpendicular, then they intersect at right angles. Yeah, that's also true. Cool. So we can write this as a true biconditional, we could say. Two lines intersect at right angles if and only if they are perpendicular. Hopefully you know how to spell that. We're going to need that word a bunch this year. Okay? That's it. We are done.